Welcome you all to the course Database Management System. Myself, Mohammad Hasifuddin Mondal, Assistant Professor, Department of Computer Science and Engineering, Narula Institute of Technology. And this is lecture number 37 of this course. Here I am going to cover recovery management. And these are the topics which I am going to cover during my lecture. First, I will discuss about different types of failure that we may observe in any system. Then I will discuss about recovery algorithms, though the details of the recovery algorithms is going to be covered in the next lecture. Then I will give an idea of storage structure. Then I will discuss how the databases or the data members are being accessed by the transaction in details. Then I will discuss about recovery and atomicity. Now, like the computer system, like any other devices, is subject to failure, and the failure may be occurred due to several reasons like system failure, disk failure, power failure, or software error. So due to all of this, a system may fails. Now, as we know that transactions are executing any computer system. So if system fails, transaction definitely is going to be failed. And if transaction fails during their execution, then that transaction properties like atomicity property, consistency property, and durability property may happen. So the responsibility of the database system is to ensure all these property even if the transaction failure. That is why there is a component in the database system is that recovery management component, and that recovery management component has the responsibility to ensure the acid property like atomicity property, consistency property, as well as durability property instead of transaction fails during the execution. So now discuss how to classify this failure. The first failure is transaction failure, means the transaction is failed due to transaction itself. One category under this failure is the logical error, means transaction is not able to complete its normal execution as because there are some internal error is there in the code or in the program of transaction. Maybe some wrong logic has been written by the programmer, or the variable which they are trying to access is not declared properly. That all this kind of logical error or the internal error within a programming code of a transaction are the part of logical error, and due to logical error transaction not able to complete its normal execution and it fails. The other is system error. Suppose a transaction code has been written, and suppose the transaction code has been written in such a way that they are not following the two-page locking protocol or timestamp based locking protocol, means concurrency control component scheme has not been employed. That is why what may happen that more than one transaction is try to access a common databases, and which may lead to the deadlock scenario. That means computer system will become in deadlock situation, and that is why no transaction can proceed their normal execution. So one of the transaction needs to be rolled back, and that is why transaction may fail. So this is the kind of system error that we may observe. So apart from transaction failure, the transaction may fail due to not itself of transaction rather than system crash. Means transaction not able to complete its execution due to the system crash. System crash means it involves power failure or hardware failure or software failure, or it may be the operating system crash. So due to all these reasons transaction may fail, though transaction have no problem, no internal problem within it, but still transaction fail due to the other problem like system crash. And here assumption is that the non-volatile storage contents are assumed not to be corrupted by the system crash. That means non-volatile means the hard disks. So whatever the content we have in the hard disks are supposed not to be corrupted by the system crash. Means if the system crash happens, then also all the content those are residing in the non-volatile storage like hard disks, they are not going to be affected. But the data item those are stored in a volatile storage like RAM, they are going to be suffered, means all the data item are going to be deleted or affected for system crash. though the database system have numerous integrity checks to prevent corruption of disk data. And third type of failure is the disk failure. Disk failure means, as his name implies, disk failure, as you know, disk is a non-volatile storage, and now the hard disk fail due to, say, head crash. Head means there's a read write head is there, by which the data item, the data elements are being read and write in and from disk. So if the head crashes, then disk failure occur, or similar disk failure, and this disk failure destroy all are part of the disk storage. And if disk failure occurs, then the thing is that the non-volatile storage contents are being suffered. Definitely, if the disk is failed, then definitely whatever the content the disk has, all data will be affected and all data will be deleted. And if the disk failure occur, we can easily check whether disk failure has been occurred or not with the help of checksum. Checksum is a concept by which we can detect whether disk failure has been occurred or not. The next is the recovery algorithm. The recovery algorithm is a part of recovery management system. Means the recovery management system follows some recovery algorithm by which they ensure the database consistency property, atomicity property, and durability property despite of transaction failure. That means so it is the responsibility of the recovery management component, and the recovery management component follows some recovery algorithm. And these algorithms, how they are going to ensure this, how they are going to ensure the consistency, atomicity, and durability property. This is the focus of this chapter. Though I will be discussing all these things in the next lecture. Now the recovery algorithm basically have two parts. First is during transaction execution process, recovery algorithm have to maintain enough information about the data item which are being modified. Means while the transaction processing is in executing process, then during that execution time, recovery algorithm need to maintain enough information about the data item that are being modified, so that we can recover from the failure with the help of this information. And second, once the failure has been occurred, we have to take a necessary action so that we can recover the database state, and that database state should ensure that atomicity, consistency, and durability property are maintained. So how recovery algorithm are going to work, all the details is going to be discussed in the next lecture. But before that, we have to know some terminology those are associated with this recovery algorithm. The next is storage type. Actually, the storage media can be distinguished based on their storage capacity, their relative computation speed, as well as their resilience to the failure. And based on these features, storage devices can be classified into broadly three categories: volatile storage, non-volatile storage, and stable storage. So what is volatile storage? Actually, we already know what is volatile storage. Volatile storage is the storage where the information can only be retained only if the power supply is present. Once the power supply is goes off, then all the information stored in a volatile storage will be gets deleted. And one of the important features of volatile storage is that whatever the information stored in the volatile storage, they does not survive system crashes. Means if system crashes happens, then all the information stored in the volatile storage are going to be deleted. And other features of volatile storage is that they are their computation speed are much more higher than non-volatile storage. Means as far as the computational speed is concerned, the volatile storage computational speed is much more higher than non-volatile storage. But if we consider the storage capacity, then the storage capacity is on the lower side as compared to the non-volatile storage. But the computational speed or the faster access, the access speed is much higher for volatile storage. The example of volatile storage is the main memory, cache memory. So all this memory belongs to that volatile storage. And already I've mentioned that the volatile storage does not survive system crashes. That is very important. Next is non-volatile storage. Non-volatile storage are the storage devices where the information are retained even if power is not there. Means even if the power is not present, if the power goes up, then also that kind of storage media can retain whatever the information they have. Means information loss are not a concern due to the power failure. And this type of storage, very important property is that they survive system crashes. Means even if system crashes, then also whatever the informations are there, all the information are going to be retained in that type of storage media. And other features are that as far as the storage capacity are concerned, they can store bulk or huge amount of data. Their memory capacity are much more higher than the volatile storage. But as far as the access speed is concerned, the access speed is on the lower side as compared to the volatile storage. Means if you want to access the data, then you cannot access the data from the non-volatile storage in faster way. It's little bit slower than the volatile storage. The example of non-volatile storage are hard disks, magnetic tape, flash memory. And among these three, in the transaction management system, most of the time we are going to use the hard disks. And apart from these two, volatile and non-volatile storage, we have another one which is known as stable storage. And the basic difference, the most important difference between the stable storage with the volatile and non-volatile storage is that stable storage can theoretically survives all kind of failure. The point I've said that theoretically or mythical, it's a mythical form of storage that survives all failures. Means theoretically it survives all kinds of failure. It survives hardware failure, it survives transaction failure, it survives system crashes. So even if the system crashes, then also whatever the information it has, it retain all the information. So as far as a theoretical concept, but in reality this is not going to be happen. But as per theoretical concern is that it retains all the information, it survives all types of failure. And it's approximated by maintaining multiple copies of on distinct non-volatile media. Means how to implement that storage, stable storage. For that we have to maintain multiple copies of non-volatile media, and we'll see it how stable storage can be implemented in the next slide. So how to implement the stable storage concept? Actually, to implement the stable storage, what we have to do, we have to maintain multiple copies of each block or each data on separate disks. Means we have to maintain multiple copy of each data item on multiple disk. That means if we represent it diagrammatically, then as if we have multiple, suppose we have multiple hard disks are there. So what we have to do in stable storage concept is that, suppose we are going to deal with the data item A. So what happened, the data item A is going to be placed in three separate hard disks. That means same copy has maintained in three separate disks. So we have to maintain multiple copy of same. Now the copies, those are stored in the multiple disks. These disks will be placed in the remote site. why they are not written in the same site, rather they are distributed in geographical location, and they are actually written in the remote side, as because to protect them against the disasters like fire or flooding. And failure during data transfer, but still failure can be happen during data transfer, and which can still result in an inconsistent copies. Now three scenario may happen here. One is successful completion, means while we are updating the data item A, what we have to do, we have to update in all three data item, in all three hard disks. So if we able to successfully update the data item A on these three hard disks or the three separate disks, then what we have said that this is the successful completion of updation. The next is the partial failure, means partial failure may happen, means that these are the destination block, says the destination block has incorrect information, means suppose out of three, if we able to update only two or one disks, and out of three, two or one disks are not updated properly and one or two disks are updated properly. So that means some disks are updated and some disks are not updated. That means we have to say that this is partial failure. And what about total failure? If destination block was never updated, means none of the block, none of the disks are updated, so it's a total failure. So we have to deal with all these two kinds of failure. So what is the solution? The solution is execute the output operation as follows. Output operation means whenever we try to update the data item A or B, whatever it be, whenever we try to update the data item or the disk block, we have to perform the following operation. First, what is the thing is that, and assuming that we have two copy or three copy, whatever it be, so the first thing what we have to do is that write the information onto the first physical block, means while updating the data item, say data item is A, so what we have to do, we have to first write the information on the first physical block. Say this is the first physical block, let me mark it. So suppose this is the first physical block, so initially we have to update or we have to write the information onto the first physical block. So first we have to update the value of A in that disk. Second, when the first write is successfully completes, then we have to write the same content or the same information onto the second physical disk. If we have only two disks, then okay. If we have three disks, then again we have to, once the second disk is written successfully, then at that point of time we have to write the content of A or the same information the third disk as well. So one after another. And then what we have to do, the output is completed, we consider the total output is completed or the updation is completed only after second write successfully complete. Second write, why you are termed it second write, because we are considering only two copies of each block. If we are maintaining three copy, then we are considered the output is successful only if all the three writes are successfully complete. Now the next thing is that what we have already said, that suppose again we have three, suppose we have two copy of same data item we are maintaining, say same copy A is maintained in two disks, and these two disks are remotely placed. In all the two disks the data item A is maintained. So it may be 2, 3, 4, whatever it be. The more you maintain the same copy to the more disks, it will be safer for you, but complexity will increase. Now at that point of time, suppose we are considering only two disks. So suppose copy of a block, in that case the copy of a block means the data item. Okay, so copy of the block or copy of the data item may differ due to failure during output operation, because suppose we have updated the data item A, but we are not able to update the data item on the second disk, means we have successfully update the data item A on the first block, but we have not able to successfully update the data item A in the second block. So that is partially successful. So in that case, how to recover from the failure? So first thing what we have to do, first we have to find the inconsistent block, means which one is the inconsistent block. If there is a three copy, suppose we have three copies are there, we are maintaining another copy for data item A, and suppose we are updated the data item A on the first block, but but the updation has been failed for second block. This is the second block. Say this is second, this is third block, say this is first block, but the updation has been failed for second block and third block. So what we have to do, first we have to find the inconsistent block, which is the inconsistent block. For that, what we have to do first is we have to compare the two copies of every disk block. Means we have to compare the every block with the other one. As we know already, first block is successfully completed, that record is there. We know the system knows that first block is the correct data, updation has been done, and so what first block is the correct and actual data. So system will compare the disk 2 with disk 1. If there is some inconsistency found, then it will be easily found that block 2 is have inconsistent data. Similarly, disk 3 have to be compared with the disk 1, and again if some mismatch is found, then that means 3 has some inconsistent data. But thing is that this is expensive solution, means comparing the whole disk with the another disk is very time consuming and it will incur maximum overhead. So it's a very difficult and tedious job and expensive solution. So we have a better solution. What is that? We have to record all the in progress disks write on a non-volatile storage. Means wherever and whenever we are trying to write or update the disks, then all that operation are going to be recorded in non-volatile storage. Mainly that kind of operation are written in that magnetic tape. So whatever the data are going to be modified, that data are stored in a non-volatile storage like magnetic tape. Now if some disk failure occur, means if some failure occur to update in any disk, then what we have to do, we have to use that non-volatile storage information. So based on that non-volatile storage information, means magnetic tape information, we are going to update the disk data those have been faced the failure. And the thing is that we can use the RAID system. RAID system is for specially used for stable storage. So RAID is a concept, the term in technology by which we can implement the stable storage also. And if after comparing the disks, if one of the disks has found that inconsistency, then we have to do, we have to override the failure disk content by the other copy. And how to compare, actually what we have said, that we are comparing the content of disk 1 to content of disk 2, and content of disk 1 is the actual data and the consistent data, and content of 2 is inconsistent data. Now how to compare that? With the help of checksum, concept of checksum. The next concept is the data access, means how the transaction are going to access the databases or the data members. Actually all the databases or the data elements are actually stored in the physical block. Physical block refers to the block or the data item that residing on the hard disk. Now when transaction initiates, means when transaction start execution, what happen? The physical block are copied to the buffer block. Now buffer block means the block which residing temporarily in the main memory. In a main memory, space is occupied, which is known as buffer block. So the physical block are copied from hard disk to the main memory. Now the block movements between the disk and the main memory are initiated through the following two operation. Input B means it transfers the physical block B to main memory, means it's copied the physical block B from hard disk to main memory. The just reverse operation of input B is the output B. Actually it transferred the buffer block B to the hard disk and replace the appropriate physical block there, means it transferred the content of block B from the RAM to hard disks. Now apart from physical block and buffer block, there is another private area there. Whenever a transaction begin their executions, suppose transaction ti is start executing, so whenever any transaction start execution, apart from buffer block, within the RAM another private area is allocated, which is only specific to a particular transaction. Means every transaction will be associated with its own private area within a RAM, and all the local copy are going to be maintained. Means the from buffer block, again the same copy is going to be copied into the personal private work area, and whatever the updation is going to be happen, all will be on the that private work area. And ti is local, suppose ti is the transaction, ti is local copy of the data item x is called by xi. So xi is the local copy of the transaction ti, which is present in the private work area. And we assume for simplicity that each data item fits in and stored inside a single block, and block means a fixed size area of, so block means a fixed size area, and we have a multiple block of memory and all the memory block are of same size, and for assumption is that all the data item x are or exactly fit into that single block. Now the transaction actually transfer the data item between the buffer block and its own private area with the following two operation: readx and writex. Now readx actually assign the value of data item x to the local variable xi, and writex is just opposite of readx. Now the transaction perform readx while accessing x for the first time. Means when transaction performs the readx operation, actually it performs the readx perform the very first time when it accesses the x, and all subsequent access are to the local copy. Means all of whatever the access are going to be made from second time onwards are all are going to be accessed from the local private copy. And after the last access, transaction execute writex. Writex means what it will happen, it will copy the content of data item x from private area to the buffer area, and output bx need to immediately follow writex. Means after writex we have to perform the output x, and all this thing whatever I have discussed, it will be clear in the next slide, as it represents a graphical representation. Suppose this is the hard disk, this is the hard disk. As we know, all the data item are, all the hard disk hd, all the data item actually are going to be stored in the hard disk. Suppose a is the database or the data item, b is another data item, and suppose t1 is the transaction, t2 is the transaction. Whenever transaction start executing, so first what happened, whatever the data item t1 is going to access, all the data item first has been copied from hard disk to the buffer. Now what is buffer? Buffer is also a part of memory of the RAM. This is RAM. So buffer is also a part of memory of the RAM. So whenever transaction, whatever the data item is going to access, first database copied the content of a and b from the hard disk to the local buffer, and this is x and y. X correspond to the copy of a, y correspond to the copy of b, and the copy operation, the copy of a from hard disk to RAM is performed with the help of input a operation. And what is output b? Output b means outputting the content of y from buffer to the hard disk. So actually input is a read operation into the local buffer, and output is a write operation from the local buffer. And from the local buffer, transaction t1 when it's executing from the local buffer, in the RAM a private area is associated with every transaction. So in a memory large, this is the large memory. So in a large memory, multiple blocks are going to be allocated for each specific transaction. For each specific transaction, a memory area is associated. That memory area is known as private area. So this is the private area of t1, this is the private area of t2. So in that private area within the RAM, the data item whatever stored in the buffer space all are copied into the private area of a particular transaction. So x is copied to the x1, y is copied to the y1. So the transfer of this content is, that means the transfer of x from system buffer to the private area is performed with the help of readx operation, and the copy of y from the system buffer area to the private area of transaction is copied into the y1 and with the help of write y operation. And another important point, whenever transaction, so and then after that, once the content of x and y are copied from buffer area to the private area, whatever the updation has been done by the transaction, all updation is going to be happen temporarily on the data item x1 and a1 y1. And once all the updation has been done, then after that, t1 transaction t1 will initiate the write operation. And what it will do, write operation will copy the content of data item from private area to the system buffer area. And subsequently, when transaction t1 execute write operation, subsequently operating system in turn it will invoke the output B operation. Now what is output B or the output operation? It will copy the content of the data item from buffer area to the hard disk. So very interesting point, whenever transaction initiates the write operation, it copies the content from private area to the local buffer area, and automatically operating system will invoke the output operation, which actually copied the content of data item from buffer area to the hard disk. Similarly, whenever transaction initiates the read operation, what happens? Automatically, uh, operating system will invoke the input operation. So what input operation will do? Input operation will copy the data item from hard disk to the system buffer area, and then from system buffer area the content of the data item will be copied from there to the private area. So that is how the whole read and write operations are performed. Now recovery and atomicity, already we have discussed all these things. We know that a transaction consists of multiple operations. So consider a transaction ti which transfer $50 from account A to account B, and our objective is to that either perform all the database modification or none at all. It is the property of atomicity property, means either transaction perform all the database updation or none are. Now what happen is that as any transaction consists of multiple output operation. Now a failure may occur after one of these modification have been made but before all of them are made. Means say suppose transaction ti has to modify 3 or 4 data item. Out of 4 data item, if ti able to update only 1 or 2 data item and rest of the data item have been not been modified, then what happened, the database system will become inconsistent state and atomicity property has been not preserved. So why? Because due to some transaction failure, it may happen that due to some failure the transaction ti is not able to update all the data item. So that is why it becomes inconsistent state and it doesn't preserve the atomicity property. So recovery system have to deal with all this type of things. Now to ensure the atomicity property despite the failure, we first output the information describing the modification to the stable storage without modifying the database itself. That means what we have tell that, just go back to the previous slide. So before performing the output operation, before writing the content from private area to the actual hard disk, what we have to do, we have to write all this information in another stable storage area. Means for example magnetic tape, means suppose we have to update the content of x1 to the a, we have to update the content of y1 to b, suppose. So before updating into the actual hard disk, we have to mm, we have to store the information related to that updation into a stable storage. For example, let me draw it. So, stable storage means it may be a magnetic tape. Say this is a stable storage magnetic tape. Suppose x1 will be updated to a, and that value is going to be, say, it is be updated, it will be updated with the value 100, and y1 which is going to update b, say it will be 200. So so that information, that type of partial information is maintained in a stable storage before updating the actual data. So first we have to update the stable storage, then it is complete, then we have to update directly on the hard disks. Why? What in that case what happen if stable storage written has been completed but during disk updation if system failures occurs, then what we can do, we can when again we reinitiate or restart the transaction, we will read the stable storage content, and from stable storage content we are able to know that what should be the value of x1, what should be the value of y1, and then we update according to that stable storage to the hard disks. Though I have what I have discussed is a very simple procedure, but apart from that we have to study two approaches to recovery technique. One is the log based recovery and other is the shadow paging technology. In the next lecture I am going to discuss log based recovery, and that's all for today, and these are the references you may go through for more details.